Hi Chem Peeps, let's do some examples. This is video 4 in my series of electron configurations. These are some example problems, not your just straightforward right on electron configuration. I have two sets of problems here. This first set that I have up here, set 1, let's get my pen out. Set 1, they want us to identify the electron configuration or the element that is represented by the electron configuration. So looking at the first example, it's pretty simple to do. As long as it's written properly, we can find the location on the table by the last thing that's written. And we're going to 3p4. So we're going to come down 3 rows. So we're in the 3rd row. We're in the P section 4 boxes in. So 1, 2, 3, 4. So we are dealing with sulfur. So this first example is the electron configuration of sulfur. And in fact, if you add up all of the superscripts here, you should get 16 electrons. Let's look at the next example. The next example, we're landing on 5s1. So the 5th row is right here. 5s1 is right here. So this is going to be rubidium. And if you add it up, you should come up with 37 electrons. Okay. The next one is a shorthand method. So we're at krypton, and then we're filling up to 5p3. So coming over here to the 5th row to the P section, 5p3 is going to take us to here. That's antimony, or the symbol SB. The next one, we have another shorthand xenon, and then we complete up to 5d6. And if we look at 5d6, we're going to be in the 5th row. Nope, I'm sorry. We're going to be in the 6th row because the D's are one behind the row, and we're going to go 6 blocks over. So we're going to go 1, 2, 3, 4, 5. See here, 1, 2, 3, 4, 5, 6. So osmium, OS. All right, and then the last one, we're going to land on 5F11. So the 5F is found right here. We're going to go over 11 blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're going to be right here. And the element is ES. All right. The next set of problems that we're going to do down here, there are mistakes. And we need to find the mistakes. So looking at the electron configuration of the first one, I'm seeing that the person that wrote this wrote things in chronological order. That is not correct. The Aufbau principle tells us that we must fill from lowest energy to highest energy. And so there are, if I count up the electrons, there are 35 electrons. This should give me manganese, and manganese should land on, manganese is found right there, it should land on 3d5. So this is not correct, this first one. Let's go to the second one. The second one, again, they do not have this in correct sequence. It goes 3s and then 3p, then 4s. So this is totally out of sync. If you add up these superscripts, we get 17 electrons. 17 electrons will take us to chlorine, which is right there. And so this is not correct. Again, it's out of sync, according to the Aufbau principle. The next one, we have a shorthand, and the shorthand is radium, or they have radium here instead of radon. We only use the noble gases for our shorthand. And so we need to use the correct element. This is not a noble gas over here. Radon is our noble gas, so it should be Rn, which has 86 electrons. Then we pick up 7s2 and 6f10. And this will give us the CF californium as our element. Let's look at the next one. We have krypton. Krypton is a noble gas. So they are following the shorthand correctly. And krypton is found right here. And that has 36 electrons. If we add up everything that we have here, after krypton, we are going to fill up the 5s. So we're right here. Then we're going to fill up the 4D, and then the 5P. So this is actually correct. This is iodine with 53 electrons, and this is correctly written. The last example, we have xenon. Xenon is a noble gas, so they are using the shorthand correctly. Xenon has 54 electrons, and after xenon, we go to 6s1, which is what they use. This is actually cesium with 56 electrons. Oh, no, 55, sorry. Did I write that right? Yeah, 55 electrons. And so this is how we can use the electron configurations in some example problems. I will return to talk about quantum numbers. This is the last thing that we are going to be talking about in this series. I hope this helps. You can find many lessons on this on Kim's Chem Chat, both on YouTube and TikTok. Talk to you later.